All right. So what we have here, this is 6.2a triangle proofs. And to start off, we've got a drag and drop problem here. This is one where we're given the fact that side JK and side NK are congruent, and that A is the midpoint of segment JN. Okay, A is the midpoint of JN. Now, what I would recommend you do, because you're always going to be given a diagram, okay, you'll always be given a diagram. What I would recommend that you do is you always mark on the diagram the given information, like it's already been marked on here for us, at least the congruent side part has. I would also mark on your diagram any other information that you know to be true, right, but may not be part of the given information. For instance, things that you can look for are things like shared sides. Okay, we know that that shared side is congruent to itself and it's part of both triangles. So we should mark it. Okay. Other things you might be able to mark might be if you have parallel lines, you might be able to mark some alternate interior angles. If you've got a perpendicular line, you might be able to mark some right angles. If you've got a vertical angle pair, you might be able to mark the vertical angles. But again, we need this information because we need to find a way of proving these two triangles are congruent. Now, the other thing that we're going to need to mark on here before we determine which one of our theorems we're going to use is the fact that we've got A as the midpoint. Okay, A is the midpoint of segment JN. Well, because it's the midpoint, we know that that midpoint divides the original segment into two smaller but congruent segments. Okay, so we know that JA is going to be congruent to segment NA. All right, so it looks like we have enough information to use side, side, side as our proof here. Let's go ahead and let's drag some things in here and let's complete our proof. It's me. You don't have to do it this way. You'll see some people that actually, if we're going to use side, 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 they'll actually put their items in here in that order, in the pair of side, side, side. I like to put all my given stuff in first because once it's in the proof, I can use it anywhere below that point. Okay, so I'm going to go ahead and put my given things in. So let's see, we got JK is, hold on, undo. There we go. JK is congruent to NK. That is one of my given statements, and I'm going to use given here for my reason. My other one, A is the midpoint of JN. I'm going to slide that in right there. That's our second one, and that is also given. Okay, so we got our two given statements in there. All right, now of these given statements, all we're able to say just from our given statement, all right, is that we have one pair of sides. Okay, and I put a little S there just to remind myself that I've got one side pair proven so far. I need to get two more. All right. Easiest one to get, it's that shared side, using the reflexive property. So I'm going to go ahead and do AK is congruent to AK. And we know that to be true based on the reflexive property. All right, number 4. Well, I'm going to go ahead and mark down, that's my second pair of sides. We now need to get our third pair of sides. It's this one. The JA is congruent to NA. That's going to be our third pair of sides. Now, this is important. We can't just say this. Like just saying A is the midpoint isn't enough to say that the sides, these JA and NA, are congruent. We actually have to say it. Okay, if we're going to use side, 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 at some point we have to show all three pairs of sides congruent. And the reason why we know these are true, these are congruent, is because of the definition of midpoint. Right? If you have a midpoint, the definition of midpoint tells us that midpoint divides a segment into two small segments that are congruent. these are the two small segments that are congruent. Therefore, they're congruent by the definition of midpoint. Remember your last step, the statement needs to be what you're proving. Triangle JAK is congruent to triangle NAK, and we are using the side, side, side congruence postulate. Okay, pretty straightforward. Let's say the most difficult part here is that midpoint part. There's a couple items that happen like this. Using a midpoint is one of the things that you may be given, which then gives you two congruent segments. We're going to use a couple of the others along the way as well. So you'll see a couple of the different given statements that are going to imply some other congruent parts. Okay, there's actually 6, 1, 2, 3, 4, 5, 6. There might be 7 examples. I don't know if we'll get through all these. All right, this one we have N is the midpoint of segment LW, and N is the midpoint of segment SK. So we're given the fact that we have a midpoint along 2 big segments. That's why we can say that LN is congruent to WN, SN is congruent to KN. And the other thing that's been marked in here for us is our vertical angle pair. Now it's not given, all right? That's not given, but all vertical angle pairs are congruent. So we can mark it. And it looks like we got enough information to use side angle side, okay? Remember, it's got to be side angle side because the angle's in between the 2 congruent side pairs. All right, let's go ahead. Let's put our given information in there. N is the midpoint, and N is the midpoint of this segment. And both those are given. All right, so good. So far, so good. I'm going to do my vertical angle pair. Again, I could go right into the congruent segments. I don't have to. I don't know. Whenever I see a vertical angle pair, I almost feel like that it's a given thing to us, even though it's not in the given statements. So I like to make sure I don't forget about it, and I put it in there right away. So LNS is congruent to WNK, and because we know that vertical angles are congruent. Now, you could shorthand that and write like vertical, you could write like vertical angles, then the congruent symbol, okay? But we know that vertical angles are always congruent. All right, now I'm going to go to my segments. LN is congruent to WN. Oh, it looks like, and this, you are allowed to do this. We are combining, okay? We are saying that LN is congruent to NW. These 2 single hashed segments are congruent, comma, SN is congruent to NK. The 2 double hashed segments are congruent. We can say it because we're using the same reason for both of these things here, okay? Same reason why we can put two facts in our statements that are given, okay? You can do the same thing here if you're using the same reason, definition of midpoint, all right? If you use the same reason, you can put them in the same statement. You could split these up and we could make this 6 statements long and it would still be perfectly correct. Let's see, let's just go in here and double check we got everything we need. We should have side angle side. So looks like we got side, angle, and side. We got to have all 3 parts to prove that we can use that side, angle, side, that the triangles are congruent, and looks like we got them all in there. We can now say triangle LNS is congruent to triangle WNK based on side, angle, side. All right. Now, the last of these don't involve drag and drop. We're going to be writing our answers in. Sometime on your homework tonight, there's going to be some things that you're going to have to input yourself. And some things are going to be drag and drop or like a drop down selection. But most of the diagrams are blank like this. So I would recommend either redrawing it on a sheet of paper for yourself or using the drawing tools that you have available to you in Edulastic. Okay. All right, let's go ahead and work through this one. So we got our given information. BC is congruent to DC and AC is congruent to DC. So first thing I'm going to do is I'm going to mark my given information on my diagram. BC is congruent to DC, and AC is congruent to EC. All right. Now, after we've marked our given information, we look and see if there's any other implied information. And what I see is a pair of vertical angles. So vertical angles give us a pair of congruent angles. All right, looks like we've got enough for side angle side again, similar to our last problem. Let's go ahead and write in what's missing. So in our reason, it says there's only one given reason over here. So I think I got to put all my given information up top. So side BC is congruent to side DC, and AC is congruent to EC. The vertical angles theorem, that's our reason, so I better be proving two vertical angles are congruent. Angle BCA is congruent to angle DCE. You have to be careful. You cannot just say angle C is congruent to angle C, all right? Because angle C could be, there's like 8 different angles here at point C. I got angle ABC, angle ACE, angle ACD, angle ECD. There's a lot of different angles here at point C. So I got to be clear which 2 angles, which is why I got to use the 3 points. Once I have this information, because now I have side, angle, and side present, I know the triangles will be congruent based on side, angle, side. Okay, pretty straightforward. All right, here's one where we are given 2 congruent sides. We got JK is congruent to LM. Sorry, is congruent to LK. I'm going to mark those. And JM is congruent to LM. And we have a shared side, which tells us that is congruent to itself. Even though it's not given, it is implied. All right. Looks like step 1 should be our given step. Let's put our given information in there. JK is congruent to LK. JM is congruent to LM. Given. Reflexive property, I'm talking about the shared side. KM is congruent to itself, KM. Once I've done that, I have enough information. I've got side, side, side to use side, side, side to prove the triangles are congruent. Make sure this statement looks exactly like what you're trying to prove. KJM is congruent to triangle KLM. There we go. Looks good. All right, moving on. Number 3. Okay, here's another one that good to talk about here. We've got a different part here. Bisects. Okay, it says that side FH bisects angle GFI. Let's talk about how we're going to use this. Well, let me mark my given fact here. Angle G is congruent to angle I. So this angle is congruent to this angle. All right. And we're told that FH bisects angle GFI. So it bisects this big angle. Now, bisecting an angle, we can't use that as our reason. Okay, that can't be our reason for immediately saying these 2 angles are congruent, but we do know that a bisector of an angle does cut the angle into 2 smaller and congruent angles. So angle GFH is going to be congruent to angle IFH. All right. Now again, I can't use, so let me see, do I have enough? Oh, I've got my shared side as well. So it looks like I can use angle side. Okay, it looks like I'm going to be using angle side. I can't use angle side angle because I don't have, the side is not in between the 2 angles. So it's outside the 2 angles. So I have to use angle side. Now again, I can't use this fact as the angle, but I can use this as the fact to then put a statement that the angles are congruent. All right. So let's see here. Oh, first one's given. I can say angle GFH is congruent to angle IFH because of definition of bisector. Okay. Because we know that FH bisects this angle. So these two smaller angles are congruent because of the definition of bisector. Our reflexive property, we're talking about the shared side. FH is congruent to FH. Last, we should have enough information to prove it. Let's see, we got angle, angle, side. We're good. We got triangle GFH is congruent to triangle IFH. Angle, angle, side. Nice. All right. I think we might have time to get through all these. All right. And these are similar to what you're going to have on your homework. You're going to have some blanks. You won't have completely blank. But we're trying to put the blanks in different places so you guys have a good idea of how these should be formatted. All right. Given angle N and angle Q are right angles. So angle N and angle Q are right angles. Okay. NO is congruent to PQ. NO and PQ are congruent. All right. Any other parts here? We got the shared side. PO or OP is congruent to itself. All right, let's see what we got here. It looks like we didn't put all of the given information here, but angle N and angle Q are right angles. That definitely was given. Okay. Now, because we have a right angle in both triangles, we can say the triangles are right triangles. Now, why would we need to say they're right triangles? Well, let's look at what we're given. We can't use side angle side because the angle is not between the two sides. We aren't given two angles because we're not told anything's parallel or anything like that. So these right angles are key because I think we're going to have to use hypotenuse leg. Hypotenuse leg. All right. And part of hypotenuse leg, the three parts you have to prove in hypotenuse leg is that one, you have a right triangle. Two, the hypotenuse is congruent in both triangles. And three, you have a leg that's also congruent. All right. Now we've got the right triangle part right here. So there's the right triangle part. We're given the leg part, which actually happens here in step 4. I like to put this at the beginning, but they put it further down, which is fine. This is one of our given facts. Okay. NO is congruent to PQ. That's our leg. We need to prove the hypotenuse is congruent to itself here. So let's do PO is congruent to PO, reflexive property. And that's our hypotenuse. So we got a right triangle, the hypotenuse, and the leg. We got all three. We're good there. You can say triangle ONP is congruent to triangle PQO by hypotenuse leg. Right. Okay, these last two, I definitely want to go over because they involve just some other facts that you are going to see. This one, all we're given is the fact that we have two pairs of parallel sides. It says ST is parallel to RU, SR is parallel to TU. Now, we've already marked the things that we can get from this. We know I marked these as parallel because we're given that they're parallel. All right, that's what these arrows are for. And then we can also mark that these angles are going to be congruent to each other. That is what parallel lines imply. They imply congruent angles. Now, how can we say they're congruent? They're congruent because they're alternate interior angles. If I look at ST and RU and this line down the middle as the transversal, right? Then angle STR will be congruent to angle URT because they're alternate interior angles. If I look at the two side segments going up and down, we can say those two angles that are double RT are going to be congruent because they're alternate interior angles. All right, well, let's go ahead and see. We also have the shared side. So I think we're going to be able to use angle side angle in proving this. Okay, let's see if we can go through here and get that. Now, none of the given information gives us, we don't have enough information to mark angle side angle right away, okay? We could get our side pretty quickly because it's shared, but we gotta prove that these angles are congruent within our proof. So this first one is given. We were given that these two lines are parallel. All right. Now it looks like down here, actually I'm gonna write down given for here as well. Looks like what they're doing in this proof is they're proving because of these two lines, we know that we have a pair of angles that are congruent. So let's look at ST and RU that we got they got the congruent angles of these two angles. So that's angle STR. STR is congruent to angle URT. Right? And the reason why we can say them, now they wrote it out all the way. If lines are parallel, alternate interior angles are congruent. If you guys may see it just written as alternate interior angles congruent, AIA congruent. Okay, that's enough information for our proofs right now. It may be written all the way out. Just depends on the problem that you get. Okay, now that gives us an angle. We also, in number 4 here, we're showing the double arced angles are congruent, and we're using the same rule. Okay, we're using that same rule. We just used it with the other two lines, which were given to be parallel. So that's our other angle. Now we're missing our side in between the two. Well, that's our shared side. RT is congruent to RT, and that's the reflexive property. Well, there's our side. Angle. This will actually be angle side angle because the side's in between the two angles. And we can say that triangle SRT is congruent to triangle UTR. Okay. All right, last one. All right, here we have angle W and angle Y are right angles. Angle W and angle Y are right angles. So I will go ahead and mark these as right angles. Vx is congruent to Zx. So Vx is congruent to Zx. And X is the midpoint of WY. X is the midpoint. Now remember, being the midpoint tells us that the two small segments will be congruent. Okay. Now, we've got to use a couple of these facts, though, to get the information we need. This is another one we're going to use hypotenuse leg. Okay. And again, remember the 3 facts you need with hypotenuse leg. You've got a right triangle, your hypotenuse is congruent, and your leg is congruent in each triangle. And one leg is congruent. Okay. So let's go ahead and figure out how we're going to get from top to bottom here in our proof. Angle W and Y are right angles. Well, that was given. That comes right from our given statement. Good. Now, this second reason says definition of right triangle. All right. This is where, remember the 3 things. We got to prove that these are right triangles. We have to say that. Okay. We have to say triangle VWX and, sorry, my and symbol's a little off, and triangle ZYX are right triangles. Okay, we have to say that. That's one of the three things we need to prove in order to use hypotenuse leg down here in our last reason. Okay, so that's where we get definition of right triangle. If you have two triangles and each triangle has a right angle in it, then both triangles are right triangles. All right, looks like, so there's our right triangle fact. Looks like the other two given things are right here in step 3. And within one of those, we actually are given our hypotenuse. That's what the Vx congruent to Zx part is. Now we need to prove our leg. Just saying X is the midpoint is not enough. We can't just say, oh, there, we got our two leg segments, we're done. No, we got to show the leg segments. So we can now say Wx is congruent to Yx. And why? Because of the definition of midpoint. Okay, there's our leg. So we can say triangle VWX is congruent to triangle ZYX. Reason, hypotenuse leg.